This lesson is going to be about how to solve equations that happen to have radicals as a part of them. Steps for solving any radical equation are essentially going to end up being the same every time. First off, you want to isolate the radical. Doesn't matter which side you prefer to isolate things by, but the same way, when you first learned how to solve for a variable in general, and they would say, if you're solving for x, that's usually the variable that we use, get x by itself, isolate the variable. Well, it's the same idea here. You want to isolate the radical. After you've isolated the radical, you want to figure out whatever the type of radical is, whatever the power of the root is. So, if it's a square root, that's 2. If it's a cube root, that's 3. Fourth root is 4, so on and so forth. Whatever that type of root is, you want to take each side to that power. Because we know that exponents and radicals can cancel each other out if they are matched with the right power. So a square root is canceled out by squaring, taking to the second power. A third root is canceled out by taking something to the third, so on and so forth. That's pretty much your steps to solving, and then you're just going to end up solving the same way you would any other time after that. What's important and what's special with radical equations compared to some of the other more basic equations that you've probably solved out in your time with math is it's really imperative, it's really important that you check your answer every single time. Because with radical equations, and there's a few other types of equations as well, but you could end up with extraneous solutions, meaning basically numbers that seem like they should be answers for this, but in reality are actually not. Now, we'll have some examples where that'll happen, so I'll show you what that means. For first example, let's say we had the square root of 2x plus 8 is set equal to 10. And we are asked to solve that out. Okay? Well, first thing, we want to make sure the radical is isolated, meaning that there should be nothing on the side of the equation with the radical that is outside that radical, or in this case, a square root. Well, there isn't. We only have a 2x and an 8 on the left side of the equation, and they are both underneath, they are both inside that square root. So the radical is isolated. So we move on to the next step. We want to figure out the power of the root and then take each side of that power. Well, a square root is really a second root, so we would want to take each side to the second power. We want to square each side. All right, certainly we have to do it to both sides to make sure we're still balancing the equation. If we square both sides, the square root and that square cancel out, leaving us with just 2x plus 8 on the left side, which is the whole point of our method of solving here, is that stuff's always supposed to cancel out. That's why we isolated the radical. But on the right side of the equation, we really do need to take 10 squared, which would give us 100. Now that we have canceled out the radical, you just solve this out like you would any other type of linear equation, any other type of normal equation like this. We're trying to get x by itself. So our first step would be we want to subtract 8 to the other side, 100 minus 8, giving us 92. Then we'd want to divide by 2, and 92 divided by 2 would give us x equals 46. Now we did all our math correctly, everything is perfect with that, but we have to plug that 46 back in to the original equation to make sure it really does work. So I go back up to the original equation, which was the square root of 2x plus 8 equals 10, and I am now going to plug 46 in for x to make sure we get a true statement. So we'd have the square root of 2 times 46 plus 8 equals 10. 2 times 46 is indeed 92. So we have the square root of 92 plus 8 equals 10. 92 plus 8 is 100. And last I checked, the square root of 100 was indeed 10. So this does give us a true statement. It checks out. So x equals 46 really would be our answer for this problem. Let's look at another example here. This time we've got the square root of 6x minus 5 plus 9 equals 2. Now the difference with this example compared to our last one is this time our radical is not isolated for us. We're going to have to do that ourselves. Recognize that what I mean there is the radical, the square root of 6x minus 5, is on the left side of the equation, And there is also a plus 9 on the left side of the equation that is not inside that radical. Since it is not inside that radical, we need to get that moved to the other side to get the radical isolated. Because if we squared now to cancel out that square root with the 9 where it is, you suddenly have a foiling problem because you're having to square a quantity where you have an a term of square root of 6x minus 5 and a b term of 9. And you don't want to have to do a whole bunch of work with that when it'd be much easier if we just subtracted 9 to the other side of the equation. That way, we'd have the square root of 6x minus 5 equals negative 7. Now we have the radical isolated, so we can move on to that second step and start trying to cancel out the radical. Well, the opposite of square rooting is certainly squaring, just like we had already talked about. So if we square both sides, then that would mean we'd have 6x minus 5, because the square root would cancel out, and then negative 7 squared would be a positive 49. Right? Don't forget that any negative number squared turns positive because squaring means to multiply a number by itself, and a negative times a negative is a positive. Well, now that we've done that, we're back to where we were with the last problem, where we just have a pretty simple linear equation that we can work on solving out. So we'd want to start by adding 5 to the other side. So we'd end up with 6x equals 54. Then we would want to divide by 6. 54 divided by 6 giving us that x equals 9. Which is great. We did all that math correctly. But again, we now need to check that answer to make sure it really does give us a true statement before we say its actual answer and circle it and everything. So our original problem was the square root of 6x minus 5 plus 9 equals 2. And so we want to plug in 9 for x and see if that gives us a true statement or not. That means we would have the square root of 6 times 9 minus 5 plus 9 equals 2. 6 times 9 is 54. So we have 54 minus 5 inside the square root, and the plus 9 equals 2. We're just rewriting at this point. 54 minus 5 is 49. So we have the square root of 49 plus 9 equals 2. The square root of 49 is 7. Positive 7. 7 plus 9 does not give us 2. 16 equals 2 is not a true statement. Since that is a false statement, since 16 does not equal 2, it turns out that x equals 9 doesn't really work out. Since that's the only answer that we were able to find algebraically, we are forced to give an answer of no solution for this problem, because the only number we were able to find algebraically did not actually work out. So this equation must simply have no solution. This is why you have to check your answer every time you're solving a radical equation, just in case, because you never know.